Hey everyone, and welcome to today's Explainer. I am absolutely thrilled to have you here. Today we're taking a deep, structured dive into the evolution, the breakthroughs, and the monumental real-world impact of generative AI. Whether you've been following this tech for years or you're really just starting to see how deeply it's weaving into our daily lives, we're going to break down exactly how we got here, and more importantly, where this incredible technology is heading.
I mean, think about it. How did we go from a basic 1950s checkers program to machines that can literally think, step by step? It's nothing short of a technological hero's journey. We aren't just talking about code that spits out pre-programmed answers anymore. We're looking at systems that plan, that reason, and that create. Understanding this trajectory is absolutely crucial for navigating the world we're living in right now.
So here's our roadmap for the Explainer today. We'll start with the origins and AI winters, move into the deep learning breakthrough, explore the era of reasoning, look at real-world AI applications, tackle the controversies, copyright, and risks, and finally wrap up with the future of generative AI.
All right, let's jump right into part 1, Origins and AI Winters.
You know, AI isn't exactly a new concept. Way back in 1952, Arthur Samuel actually coined the phrase machine learning while he was putting together a program to play checkers. And by 1961, Joseph Weizenbaum had created Eliza, which was the world's first talking chatbot, designed to sound empathetic. But it wasn't all smooth sailing. Early hype around basic pattern recognition led to these massive, dashed expectations. When the tech just couldn't deliver on all those wild sci-fi promises, the funding completely vanished in 1973 and again in 1984. We call these deep freezes the AI winters. Skepticism peaked, and honestly, the term artificial intelligence was almost spoken with contempt by the broader scientific community.
Moving on to Section 2, the deep learning breakthrough.
Okay, so let's dive into how the technology resurrected itself. A huge pivotal turning point hit in 2014 with Generative Adversarial Networks, or GANs. Now, a GAN is brilliantly simple in theory, but incredibly complex to actually pull off. It basically pits two neural networks against each other. You have a generator creating synthetic data and a discriminator trying to spot the fakes. They train simultaneously, locked in this intense digital arms race. One gets better at making forgeries, the other gets better at catching them. And this specific breakthrough is what finally allowed AI to create highly realistic, authentic-seeming images, videos, and audio. It literally taught machines how to trick the discriminator and, eventually, how to trick our own eyes and ears.
But processing language, that was a whole different beast. The industry needed a totally new architecture. Enter transformers in 2017. The true magic here is this concept called self-attention. See, previous models read text sequentially, word by word. That was slow, and they'd lose context over long paragraphs. Transformers, however, process tokens, which are basically just chunks of words, in parallel. They dynamically weigh the context and the relationships between all the words in a sentence at the exact same time. This breakthrough completely replaced traditional models and laid the essential groundwork for OpenAI's Generative Pre-trained Transformer series. And yes, that is exactly what GPT stands for.
Which brings us to Section 3, the era of reasoning.
So just a really short time ago, standard large language models actually required humans to explicitly prompt them with phrases like "think step by step," just to coax out a logical answer. But these new reasoning models, like OpenAI's O1 and DeepSeek R1, they totally changed the game. They use reinforcement learning to evaluate and autonomously think before they ever output a single word to you. By rewarding the model during training for correct logic, the AI naturally learns to plan, backtrack, and reason through incredibly complex problems entirely on its own.
43. That is a staggering 43 percentage point improvement that OpenAI's O1 model had over its non-reasoning predecessor, GPT-4o, on highly competitive AIME math problems. It didn't just guess better. It autonomously thought through the math better. It's wild.
Let's look at Section 4, Real-World AI Applications. Because AI isn't just writing polite emails or generating funny pictures anymore. DeepMind's AlphaDev actually discovered new, faster computer sorting algorithms that human engineers had missed for a decade. AlphaEvolve goes even further, using LLMs to invent entirely new general-purpose algorithms right from scratch. And incredibly, AI co-scientists generated and validated a real research hypothesis regarding microbial antibiotic resistance. It matched exactly what human scientists were working on at the exact same time. This brilliantly illustrates how AI is no longer just a tool. It's acting as a genuine, high-level research partner, driving unprecedented scientific and mathematical discovery.
To truly grasp the staggering scale of this adoption, think about this number, 60,000. Researchers estimate that in the year 2023 alone, over 60,000 scholarly articles were likely written with LLM assistance. That's about 1% of all academic publications. The integration of this technology into our professional and academic lives is happening at lightning speed. What you should really take away from this is that working alongside AI is rapidly becoming a baseline professional expectation.
Now for Section 5, Controversies, Copyright, and Risks. We absolutely have to address one of the most fundamental legal questions of our time. If AI generates the art or the text, who actually owns the copyright? This single question has sparked massive, ongoing lawsuits from major entities like Getty Images and the New York Times against AI developers. It was also a primary driving force behind the historic 2023 Hollywood writers and actors strikes. Creators all across the globe are feeling acute existential pressure right now.
Here is the core legal tug-of-war. On one side, AI developers argue fair use. They claim that training models on massive amounts of internet data is a highly transformative use, and it doesn't make direct copies available to the public. On the other side, copyright holders argue copyright infringement. They point out that these AI models compete directly with human creators and, in some cases, can generate near-identical copies of original copyrighted works. Now, the U.S. Copyright Office has currently ruled that purely non-human works cannot be copyrighted, but the legal landscape here is highly fluid and it's still being written.
Beyond copyright, there are also serious malicious risks to consider, like information laundering. A recent report by Graphica looked at Chinese state media and outlined this process in 3 distinct steps. First, state-backed propaganda is produced. Second, generative AI is used to quickly rewrite the text, altering the tone and style to completely disguise its true origin. And third, these laundered articles are covertly spread across social media platforms to manipulate users. The technology's ability to seamlessly and endlessly generate text really does make it a potent weapon for disinformation.
Finally, Section 6, the future of generative AI. Now, what's really interesting here is the sheer computational cost required for AI to actually think. Take a look at the Gemini 3 Flash model on a standardized intelligence index. Without reasoning enabled, the model used 7.4 million tokens to complete the benchmark. But with reasoning enabled, allowing it to actually think step by step, it used 160 million tokens to achieve a higher score. That is a colossal jump in compute. It means that while these reasoning models are absolutely brilliant, they are incredibly resource-intensive to operate.
And those massive computational resources have a very real, physical footprint. By the year 2035, the annual CO2 emissions from generative AI could reach up to 245.9 million tons. To put that staggering number in perspective, it rivals the entire U.S. beef industry, which currently emits about 257.5 million tons annually. The electricity required to power the chips and the fresh water needed to cool these massive data centers represents a profound and growing environmental challenge that the industry absolutely has to face.
Which leaves us with this final provocative thought to end our explainer today. As AI autonomously learns to reason, how will we govern its logic? We have successfully built machines that can outcalculate us, invent new algorithms, assist in groundbreaking medical science, and generate endless creative content. But finding the balance between unleashing that transformative potential and managing its deep societal and environmental impacts, well, that's going to be the defining challenge of our generation. Thank you so much for joining me on this deep dive. Keep learning and keep questioning the technology that is shaping our world.